Introduction. Welcome to the audio revision of Chapter 1, Scientific Study and Units. In this chapter, we explore how scientists study nature using experiments, logic, and measurements. We'll also learn about variables, their types, and how we measure physical quantities using units. Let's get started. Speaker: high-volume scientific study. Science is the logical and systematic study of the natural world. It includes facts, theories, models, and experiments. Scientists investigate the causes and effects of natural events using scientific methods and measurable evidence. When we see something happening in nature, like a plant wilting, we get curious. Why did it wilt? Was it due to lack of water? Too much sunlight? That curiosity is the starting point of scientific investigation. By testing different conditions, like watering the plant or moving it to the shade, we find out what caused the change. This helps us predict what might happen in the future under similar circumstances. Speaker: high volume. What are variables? In science, a variable is any factor, trait, or condition that can change or be changed. For example, in the catapult experiment using a rubber band. You chain how much the rubber band is stretched. You observe how far the paper bullet travels. Both of these, the stretch and the distance, are variables. Pushpin: a variable is any physical quantity whose value can vary. These are essential to understanding cause and effect in science. Speaker: high-volume types of variables. Variables in experiments are classified into three main types. 1. Independent variable. This is the variable that you change deliberately in an experiment. It is the cause. In our rubber band catapult experiment, the amount of stretch is the independent variable. You decide how far to stretch the band: 4 cm, 6 cm, 8 cm, or 10 cm. Test tube: more examples. Amount of sunlight in a plant growth experiment. Time of exercise in a heartbeat experiment. 2. Dependent variable. This is the variable you measure or observe. It is the effect, and it depends on the independent variable. In the catapult example, the distance traveled by the paper bullet is the dependent variable. It changes depending on how far the band was stretched. Test tube: more examples. Growth of the plant, depending on sunlight. Heartbeat after exercise, depending on duration. 3. Controlled variables. These are all the other variables that must be kept constant throughout the experiment to keep the test fair and results valid. In the catapult experiment, you must keep the thickness of the rubber band and the size of the paper bullet the same in every trial. If you change too many things at once, it becomes impossible to know what caused the change in the result. That's why we control everything else except the independent and dependent variables. Test tube examples of controlled variables in other experiments. Water, air, and fertilizer in a plant experiment. Type of exercise in a heartbeat experiment. Pushpin: important rules. Use only one independent variable. Have one dependent variable. Control all other variables for accuracy. Speaker: high volume, representing variables mathematically. Each variable is usually given a symbol to make writing easier. For example, stretch of the rubber band equals E. Distance traveled by the paper bullet equals X. If there's a direct relation, we may write it as X proportional to E. This shows that X distance increases as E stretch increases. In equations, we write dependent variable on the left, independent variable on the right. For example, S equals V times T. Here S is distance dependent, T is time independent, and V is speed controlled. Also, when we draw graphs, dependent variable right arrow y-axis, vertical. Independent variable right arrow x-axis, horizontal. Speaker: high volume 1.2 units in scientific measurement. To measure anything in science, we use units. A unit gives us a standard way to express physical quantities like mass, length, time, temperature, etc. There are two main types of units. White heavy checkmark 1, Fundamental units. These are the basic units that are not made by combining other units. There are 7 SI, International System, fundamental units. Quantity unit symbol. Length meter m. Mass kilogram kg. Time second s. Temperature Kelvin K. Electric current ampere A. Luminous intensity candela CD. Amount of substance mole. White heavy checkmark 2. Derived units. These are formed by combining fundamental units. They are used for more complex physical quantities. Examples. Quantity formula unit. Speed distance / time m/s. Force mass times acceleration, kg/m/s2 equals n. Pressure force / area n/m2 equals pa. Work force times distance, kgm2/s2 equals j. Power work / time, kgm2/s3 equals w. Frequency 1/time, 1/s equals hc. To find out the composition of any derived unit, break down its formula. Magnifying glass tilted left example. Force, F equals m times A. Units, kg times ms2 equals n Newton. Area, length times breadth equals m times m equals m2. Speaker high volume unit analysis, validating equations. Unit analysis is used to check if an equation is dimensionally correct. Let's test this with an example. Test tube equation, S equals V times T. S distance, right arrow M. V speed, right arrow ms. T time, right arrow s. Heavy units, M equals ms times S equals m, right arrow white heavy check mark valid. Test tube, but what about S equals V/T? Units, M equals ms, S equals ms2 right arrow cross mark invalid. Pushpin only quantities with the same units can be added or subtracted. Example. U plus V right arrow valid, both in ms. S plus at right arrow invalid, S equals m, at equals ms. Speaker high volume quick recap. Scientific research is a systematic study using observations, logic,